Hello, Geometry. We have reached the end of Chapter 2 here, and this is the granddaddy of them all. These are proving geometric relationships. We just covered two-column proofs. This last lesson covers in two other forms a lot of angle relationships. That's the most important thing out of this one, is some of the angle relationships that we're going to just work on. But these are flowchart proofs and also paragraph proofs. Okay. So flowchart proofs, what you have here is basically the steps that we would have in a two-column proof are written out in a flowchart. The reasons go underneath there. So for each step that we have here, if two things come together, they draw them together, and the reasons go in the boxes, and then, the reasons go underneath, and the statements go in the box. So this, notice, is our given. So this is going to be our given. Again, encourage you to stop and try to figure out where these should go first and come back and check this out. This one down here, AB plus BC equals AC. Okay, that's different than our given. If we look at our diagram, AB plus BC equals AC. So the two smaller parts add up to the whole. The smaller parts add up to the whole. So segment addition postulate could be transitive property. I don't think so. Or subtraction property. Well, we didn't subtract anything there right now, so this is going to be segment addition postulate. When two smaller segments add up to a larger segment. Now these two come together, they have AB plus AB equals AB plus BC. So it looks like they took this part right here and this part right here. So if AB plus AB equals AC, and AC equals AB plus BC, then AB plus AB equals AB plus BC. So that is the transitive property. A equals B and B equals C, then A equals C. So the final thing, notice it's shorter. AB equals BC. They have subtracted those things off, so of course that's the subtraction property. So that's a flowchart proof. Different than a two-column. We can write a two-column proof that would have 4 steps. This would be our first step, this and given. This would be our second step. Here's our third step, and here's our fourth step if we're doing a two-column proof. Let's practice with this one. So we have the measure of angle 1 equals the measure of angle 3. We're trying to prove that 1 and 3, that's our given. We want to prove that EBA 2 plus 3 equals CBD 1 plus 2. So here's our given, always the first one, we like that one. We're going to group that with measure of angle EBA is 2 plus 3. So EBA, I look at my diagram, not sure what they're doing, EBA is the big one, it's 2 plus 3. So the two smaller angles add up to the big one. That's going to be the angle addition postulate. Angle addition postulate. Measure of angle EBA equals 2 plus 1. Well, here is 2 plus 3, but we also know 3 equals 1. So, time to say, okay, is this a substitution or is this a transitive? We did not replace an entire half of an equation. So this is, I think, is going to be substitution here because in this formula, they replaced one thing with another. So I'm going to call this then the substitution property. Now we're going to keep going. If we run into a hitch and we think something else should be substitution, we come back and we'll fix it. Okay, measure of angle EBA, that stays the same. That hasn't changed. Equals 1 plus 2. So instead of 2 plus 1, they want 1 plus 2. That's the commutative property. A plus B equals B plus A. Now they said 1 plus 2 equals CBD. So CBD is 1 plus 2. There's another angle addition. And then EBA equals CBD. So if 1 plus 2 equals EBA and 1 plus 2 equals CBD, now that makes sense to be the transitive property. The whole side of it is equal to it. Okay. A lot of your examples, you will have steps and you'll just have to plug in the pieces. Sometimes you have to plug in the statements, sometimes you have to plug in the reasons. Alright, so we will have, I'm Mrs. Dirksen, recording geometry lesson right now. Can I come find you in a little bit? Okay, thanks. We will have two types of proofs right here, flowchart proof and a paragraph proof. Paragraph is just writing out as a paragraph our statements and reasons. Okay, we'll see that here in a little bit. Now, a lot of these are going to seem like common sense, and hopefully they do, and that is okay. The right angle congruence theorem is that all right angles are congruent. Oh, go write that. Imagine that. They all measure 90 degrees. So if they're congruent, they have equal measures. All right angles are congruent. That's the right angles congruence theorem. Theorem 2.3. Second one, congruent supplements theorem. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. So what I have here, they're saying if 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 and 3 have to be congruent. If 1 is supplementary to 2 and 3 is supplementary to 2, then 1 and 3 have to be the same. So here's this little diagram. You're going to see one like this later on. Okay? So 1 and 2 are going to be supplementary. So my question is, if the measure of angle 2 equals the measure of angle 3, then angle 1 is congruent to what angle there? Okay? So if measure of angle 2 equals measure of angle 3, again, I did this on purpose. The measure of an angle will be equal. Angles themselves will be congruent. Okay? So this is the congruent supplements theorem, and we're just stating that if 2 and 3 are the same, we know that angle 1 and angle 2 are supplementary. Okay, because they form what we call a linear pair. We know angle 3 and angle 4 are supplementary, because they form a linear pair. So if angle 1 is supplementary to congruent angles, it has to equal angle 4. It's the only one left there. Okay, so congruent supplements theorems. Two angles, if they're congruent to the same angle or to congruent angles, they themselves are congruent. Where'd my other sheet go? That's the one I want. Oh no, we lost it. Oh. I got confused. I'm sorry. I'm confused too. Forgot I'd written all this on here, these other sides. So, in like ways, we have a congruent complements theorem. Okay? This is a diagram you'll have similar to this. They'll give you one measure that's 90 degrees. So that tells you measure angle ABE plus the measure of angle EBD, which is 30, has to equal 90 degrees. That tells you those two are complementary. We know the big angles are 180 because there's a straight line. So this has to be 90. These two have to be complementary. So if this is 30 degrees and this is 30 degrees, we should know that this angle here would equal this angle here. So the measure of angle ABE would equal the measure of angle DBF. Okay, so those two angles should be congruent. Linear pair postulate, if you have a linear pair, they're supplementary, so they add up to 180 degrees. This is when we start getting to some of the algebra, practicing that with that. So we have a 59-degree angle here, not drawn to scale. We have x. They want us to find that value of x. So 59 plus x, we know these have to be supplementary, so you add them together, set them equal to 180. So if you have a linear pair, you're going to add together, set equal to 180 degrees. So we get x equals 180 minus 59 would be 121 degrees. Okay, another linear pair, we're going to add these two pieces together, set it equal to 180. So I'd take 5x minus 1 plus x plus 3, that has to equal 180. There you go. Add your x's together, 6x A negative 1 plus 3, that'd be plus 2, and that equals 180. So now minus the 2 from both sides, 6x equals 178. Check that calculation. Does that work out? 29 2/3. So much for making up numbers on the run here. Okay, so x would equal 29 2/3. Now if they want you to find the actual measurements, you have to come back and plug it in here. So this would be 29 2/3 plus 3, so 32 2/3 degrees. So add 3 to that, and then this one has to be supplementary, so this should be 147 1/3 degree. 147 1/3. Vertical angles, congruence theorems. Vertical angles are congruent. So they have the same measurement, same measure. So with vertical angles, you always set them equal to each other. Set them equal to each other. So down here, if they give you one measurement and they want you to find the other two, this is the vertical angle. Sometimes they're called opposite angles. I think that makes more sense, but that's the vertical angle. So the measure of angle 2 is going to equal 40 degrees. Okay, now 1 and 3, these are going to be supplementary to 40 degrees. So if you want to find these angles, you have to take 180 minus the 40. So the measure of angle 1 would equal 140. Measure of angle 3 equals 140 because those two are vertical angles as well. Okay, had it ready to go over here. So measure of angle 1 is 140, measure of angle 2 is 40, measure of angle 3 is 140. Getting into the algebra of them, they have two crisscrossing lines, two sets of vertical angles here, and they want you to find the value of x, or maybe they'll want you to find the measure of the angle. Okay? So 2x minus 1, these two have to be equal. So 2x minus 1 has to equal 6x minus 11. So minus the 2x over, negative 1 equals 4x minus 11. Add the 11, you get 10 equals 4x. Divide by 4, you get x equals 2.5. So then you come back and you do the same thing with these two right here. Those two will go together. 4y minus 12 equals, I'm going to distribute this, 3y plus 12. I'm going to minus the 3y over. So 4y minus 3y is y, so I get y minus 12 equals 12, so y equals 24. Add that y, 12 over. Okay, so vertical angles, you're setting the opposites equal to each other. Okay, linear pairs, you're taking the two angles, you're adding them, and then setting those equal to 180. Congruence, a lot of times you'll add them, set them equal to 90. Supplementary pairs, add them, set them equal to 180. Okay, a few examples here. We did that example in class already. So when we look at this one, you're going to add them together and set them equal to 180, or do they set them equal to each other? So these are vertical angles. You would set them equal to each other. So 3x plus 1 equals 148. It's all from there. So 3x equals 147. 147 divided by 3, you get x equals 49. Okay? 49 degrees for x. Questions like these are kind of your basic ones. If we just look at 4, if this one is 117 degrees, which other number has to be 117 degrees? Okay? Has to be across. Go across there, that has to be 117 degrees. To find these, that's a linear pair. You take 180 minus 117, and you'd get 63. So this is 63 degrees. Same with this one over here. That has to be 63 degrees. Okay, and you can do the same thing for each one of these. 2, if that's 59, that's 59. Take 180 minus 59, you get 121. That would be 1 and 3. 7's the same as what we've seen. Here's a statement, write a paragraph proof. Okay, so this is what a paragraph proof would look like. They're giving us 1 is congruent to 4. So we can just say we know that angle 1 is congruent to angle 4 because it's given. So now we want to prove 2 is congruent to 3. So I'm going to say since angle 1 is congruent to angle 2, because they are vertical angles. Okay, so you see how I'm just kind of writing out my thought process, and I have to give a reason for it. So you can't just say, well, 1 is congruent to 2, and 3 is congruent to 4. Okay, why are they congruent? Because they are vertical angles. As well as angle 3 is congruent to angle 4. Okay. So, or therefore, since 2 is congruent to 1, and 1 is congruent to 4, and 4 is congruent to 3, since angle 2 is congruent to angle 1, vertical angles, angle 1 is congruent to angle 4, given, angle 4 is congruent to angle 3, vertical angles, we can conclude, this is your, as a lawyer, you're wrapping up your statement, your final defense, that angle 1 is congruent, angle 2 is congruent to angle 3 by the transitive property. So that is a paragraph proof. Just kind of writing out your statements and your reasons like that. Okay, so let's go through this one. There are no reasons here. We're going to take this and then we're going to write a 2-column proof from this right here. So we are given angle ACB. This is page 63 now. ACB and ACD are supplementary. Okay, they're a linear pair. ACB and ACD makes sense. EGF and ACD are also supplementary. So probably something with the supplementary theorem is what we'll need. Okay, so it'd be helpful to get your notes as well out right here. We have all our postulates down here if we need them, and our theorems are right up here. So I'm going to have this ready to go. So ACB, angle ACB, and ACD are supplementary, that's given. There's another given here, so our other given is angle EGF and angle ACD are supplementary. That's our other given. So from that, they're saying ACB plus ACD, the measure of angle ACB plus the measure of angle ACD, ACD equals 180. Well, we just got done talking about how they're supplementary, so this would have to be the definition of supplementary angles. Definition of supplementary angles. Notice I look back. What are we talking about? What's the context of the situation? Just think of reading about a story in English. You got to know the context, what's surrounding the information of what you need here. Okay, here's EGF and ACD is 180. Again, definition of supplementary angles. These two come together. We have a transitive property of equality that they want us to use, right? The statement. So if ACB plus ACD equals 180, and 180 equals EGF plus ACD, if we can fit this all in here, these two parts are going to equal each other. Okay, so the measure of angle ACB plus the measure of angle ACD equals the measure of angle EGF plus the measure of angle ACD. ACDC. Okay, that's the transitive property. They did a step here, subtraction property of equality. And then right here, they went from a measure of the angle to the angle being congruent. Okay? So they switched it. The measures, remember, are equal. This one is just going to be the definition of congruent angles. That's the definition of congruent angles. So if you were to write a 2-column proof out of this, how many steps would you have? And that would equal however many boxes you have up here. So there's 1, 2, 3, 4, 5, 6, 7. You would have 7 steps down here. Each of the statements come from here. So this is statement 1. I'm not going to take the time to write this all down here. Okay, you don't need. Okay, statement 1 would be angle ACB and angle ACD. Our supplementary reason 1 is that it's given. So you would have. We'd have to write all 7 steps down. The boxes go to the statements. The reasons come from underneath the boxes. Okay? So you'll need to know how you can move those about back and forth. But for right now, I'm not going to let you just watch me copy all that down. I know you can do that. Okay? And I want this. So understanding some of these proofs I know can be challenging at times, but do your best with them. We'll work through them. Keep this handy here, looking over your reasons and stuff like that. And always ask yourself why? Why am I doing this? I don't want to. So this is the end of Chapter 2. We'll work on reviewing and getting ready for a test, and then keep cruising on to Chapter 3. Good work, kids. Proud of you. Keep it up.